Okay, continuing this with how to apply moles in chemical equations. Okay, so here you see a balanced reaction between 2 moles of iron, 3 moles of sulfur, and forming iron 3 sulfide. Okay, iron 3. You look at the subscript on sulfur, that tells you what the oxidation state on iron is. So it's iron 3 sulfide. Okay. All right. So 2 moles of iron, 2 times about 55 point something. So about roughly about 110 grams of that iron. All right. And then you have 3 moles of sulfur, and so that's about 96 grams of sulfur. And then together they combine, forming iron 3 sulfide, 1 mole of it. All right. So remember the masses, just add up the masses to get the mass of the product. Okay. Because mass is always conserved. Whatever mass you start out with on the left side must equal the mass on the right side. Okay. So matter cannot be created, destroyed. So the total mass on both sides, mass of product, must equal the total mass of reactant. All right. So here you see silver and sulfur reacting to form silver sulfide. So 2 moles of silver, that's 215.8. Sulfur is around 32. So together, if you add it up, it comes to 247.9. All right. So the mass of silver sulfide is going to be exactly the same. All right. Okay. 247.9. Okay. All right. So what type of information can you get from that equation? So in the equation, you have 2 moles of sulfur, 1 mole of 2 moles of silver, 1 mole of sulfur, forming 1 mole of silver sulfide. If you take it to be at the atomic level, that means 2 atoms of sulfur, 2 atoms of silver, 1 atom of sulfur, forming 1 formula unit. This is an ionic compound, so 1 formula unit of silver sulfide. If you multiply this whole thing by 100, that would become 200 silver atoms, 100 sulfur atoms, and 100 formula units of the silver sulfide. If you take it in terms of 6.02 times 10 power 23, that means you multiply everything by 6.02 times 10 power 23 on all sides. Or you can interpret it as 2 moles of silver, 1 mole of sulfur, and 1 mole of silver sulfide. Now, if you take the mass, then each silver is, a mole of silver is 107.9 grams. So 2 times that, so around 215. And then you add the 32 together and you get 247.9 grams. And then silver sulfide, the molar mass is 247.9 grams. All right. So that is all the information, all the possible information you can get from a balanced equation. Okay. All right. So what is the term mole-mole factors is? The mole-mole factors means the relationship between either the 2 reactants here or a reactant and product, all right? So the relationship between iron and sulfur is a 2:3 relationship, all right? 3 moles of sulfur to 2 moles of iron. If you're looking at iron and iron sulfide, it is a 2:1 relationship, or sulfur and iron 3 sulfide, then it's a 3:1 ratio. Okay, so from the mole relationship we can get all of these conversion factors. All right, so we see a total here of 6 conversion factors. And these are called as the mole-mole factors, these conversion factors that show the mole relationship between the reactants or the reactant and product. Okay, it says consider the following equation. You have 3 moles of hydrogen, 1 mole of nitrogen, giving you 2 moles of ammonia. So the mole factor for hydrogen and nitrogen is 1 mole of nitrogen and 3 moles of hydrogen. Okay, so B is the mole factor for hydrogen and nitrogen. The mole factor for NH3, ammonia and hydrogen, is 2 moles of ammonia, 3 moles of hydrogen. So how do you calculate quantities using these mole relationships? So look at what's given, what do you need? Again, write up your plan, use all the coefficients, but the first thing is make sure that the reaction is balanced, and then you can write down those mole factor relationship. All right. If you need the molar mass, calculate the molar mass, and then set up the problem to identify the unknown. So how many moles of iron 3 oxide can form from 6 moles of oxygen? So the mole factors are 2 moles of iron 3 oxide to 3 moles of oxygen. All right. So 2 moles of iron 3 oxide to 3 moles of oxygen. So if you had 6 moles of oxygen, that would be 4 moles of iron 3 oxide. So how many moles of iron are needed for 12 moles of oxygen? Okay, so you have for 3 moles of oxygen, 4 moles of iron, right? So if you had 12 moles of oxygen, that would be 12 times 4 divided by 3, and that would be 16. So 16 moles of iron. We'll stop here.